Hello everyone, welcome back to the channel. I hope you guys are doing really well. Let's see today's daily challenge on Leetcode and we will also try to solve today's challenge together. So at first we will understand the problem statement in detail. So the closest equal element queries, we have this problem. You are given a circular array nums and an array queries. For each query I, you have to find the following: the minimum distance between the element at index queries I and any other index j in the circular array, where nums of j equals to nums of queries of I. If no such index exists, the answer for that query should be -1. Okay, so and return an answer of the same size as the queries, where answer I represent the result of the ith query. So I hope you did understand the problem statement. It is not very difficult to understand or something like that. You are given an array as well as a queries. You need to answer all those queries. The query of I will tell you to go to this particular index number. Okay, so let's say this query of 2, it tells you that it is 5. So go to the fifth index number. Now you know which is the fifth index number among these. It is this 3. After you go to this fifth index number, you need to see which is the closest 3 to you. Okay, now this considering this as a circular array. Now if you see, this 3 is to my left, 4 distance to my left. Okay, so distance from this to this 3 to this 3 is 4. But if you consider it as a circular array, okay, and after this 2 there is 1, and after this 1 there is 3, then you see the distance is 3, right? So 3 3 to 2 you jump one step, 2 to 1 you jump another step, 1 to 3 you jump another step, total you jump 3 steps, and that is your answer. Okay, and also for query 0, you do understand that 1 is there, so at minimum you jump 2 steps to get another 1, so your answer is 2. So that's how it is done, and I hope it is very clear. And if there is only a single occurrence of that element, you need to return -1. You see, for query of 3, in the third index you get 4, which is a unique element, right? So there is no other occurrence of 4, so you can return a simple -1 for that. So I hope the problem statement is at least very clear, and how to solve also you might get some hint. uh, it is not very difficult. Every element you take and you store their positions in the map. So what you need to do, see, queries of I will give you one value. You need to use that value as an index. Okay, so basically query of I will give you an index of the original array. Now you need to use that index in your original array. You need to go to that particular index and extract the value. Now you need to see the same repeated value occurs to my left or to my right. Okay, left or right, whatever place that particular element occurs again. So if there is x here and x here also, or x here also, okay, then you need to check that which is the nearest repeating element. What is the nearest? So if this is at an index j, this is at an index I, this is at an index k, so you need to see that which distance is smaller, k minus j or j minus I. Okay, so I hope in order to get the nearest same element, only this thing you will do. And if you are, let's say, at the last element, you need to see that, consider this as a circular array, so the first element will jump to the last element. That's what happens in a circular array. And to access the index, I hope you do know that. So if you are at a last index, let's say k, okay, you can do k plus 1 and modulo n. Okay, uh, yeah, that is how you access a circular array element. And one thing you can do very obviously is that wherever the x is present, so let's say x was present at an index number 1, at an index number 3, and at an index number 6, and the total size of the array is 7, you can store these as a vector. So you can have a map where you store value, comma, positions, vector of positions. Okay, so map of integer comma vector. So why I'm doing this? Because of a particular integer, I need to see which all positions does it occur. So in this particular position is 3, this is 1. So it means that the distance from this is 2. So such a kind of vector I need where I will store only the positions. So for example, in for x, you will store something like this here, 1, 3, 6. And now if you are asked that, hey, tell me in the query, if you are asked that go to this position, you see that x occurs. So you can easily get what is the value of x. Using the query, you'll just do nums of query of I or nums of index. Okay, that will give you the particular value you want to search, and you can see that in the map. Okay, you can go and see that in the map. Hey, where is this value present in the map? And you see that these values x, this particular value x, is present in position 1, it is present in position 3, it is present in position 6. Now you check that which is my current position and in which index that is lying. Now for that, you can use binary search, because this can be a very long array of the order of 1e5. Okay, so you can use binary search, and this will be always sorted the way you should create it. It should be always sorted. So you should, let's say, what I want to say is that, let's say your current x value is 3. So you want to know that in which position my 3 value is lying in this vector. So this position 0, this position 1, this position 2. So in order to get that which position this 3 is lying, it will be position 1, right? But you should not do a linear search over it. You should try to do a binary search and get the value of the index. Okay, you can use a lower bound for that, lower bound example, and yeah, you should get that. And whenever you get a particular index, you try to check the next index as well as the previous index. Okay, and if you are at the last element, your next index will be nothing but your previous value. Okay, the first value, and the previous index will be whatever the previous index is. Okay, so no problem with that. And yeah, in that way you are just done. You can just return minimum of whichever your left and right. So minimum of the left distance minus the right distance. Okay, you can just return something like this. So let's try to do it. Let's try to just apply whatever we think of and see what error occurs. Okay, so let's see. Let's have this n number nums dot size. Okay, and we will have to first store the map. Okay, so I will start with an unordered map only because it is more efficient, and map of int comma vector int. Okay, and yeah, you have this will tell you the particular value comma vector of positions in which they occur. Okay, so yeah, these values and positions I need to first store by iterating through nums. So yeah, that's how I will iterate, and map of nums of I dot pushback. Map of nums of I is what? It is a vector, and each element of this vector will be nothing but uh, the value I itself only. Okay, because you are storing this nums of I occurs at what particular index, and those are the things only you are storing in the map. Because for calculating the distance, obviously I will do a subtraction of the indices only, the left and the right. Okay, so yeah, I have this map ready with me now, right now, and I should also have a vector of answer with me, which should be perfectly fine to return it. I should fill it first. For that, definitely I should go through all the queries and process them one by one. So I will have iterated through all the queries, and I will first extract the index. Okay. So what does queries of I gives you? It gives you a particular index to go in the position of nums, right? That's what it gives you. So you go to this particular index, okay, and you check what is the size of the vector in this map. Okay, so if you see if the size of the vector is 0, it means that position is not there in the array. Okay, so that cannot happen. First of all, that cannot happen. Now, if the position is 1, if the size of the vector is 1, it means that only one position that value was present. It means that it was a unique value, and for the unique value, you cannot have the repeated occurrence to the right and to the left. That's why you will end up in returning -1 for that case. So, what will be the thing here? So, I will just check that. Let me have a vector also extracted. What is the vector? It's nothing but map of index. Okay, so map of nums of index, right? You go to the nums of index and extract the value and check out its value in the map. This will give you the vector of positions. Okay, this tells you the vector of position where the value occurs. Okay, vector of positions. So you will see what is the size of this vector. If it contains only one position, right, then it is very difficult because yeah, it cannot happen in that way. I mean, it will be a unique element. So I will check that if vector dot size is sort of less than 2, okay, it's 1 or 0. If it is less than 2, it means that you need to return -1. So answer.pushback of -1, and you can continue. Nothing else to do. You have pushed your answer already. You need to do nothing else. Okay. And if you want to calculate the remaining, you should calculate the left as well as the right value. So what will be the left value? So integer of left is nothing but, first let me extract in a value k. Okay, so let's find what is the index of in this vector v. Okay, in this vector v, what is the index number of this value of index. Okay, so I hope you do understand what I'm trying to do. So when we get this value 3, what is this 3? This is extracted from this query. Okay, now I know that at index 3 x is present, but I need to know that at what exact position does that occur in this vector v. Okay, so as I told you that for 3 that will be 1, and that we will find using binary search. And I hope you already know that binary search you can perform using lower bound, upper bound. Lower bound tells you which is the greater than or equal to element which is present in this array, and I want the equal to element only, so I can simply use lower bound. V dot begin, v dot end. Okay, and which element I want to find? I want to find the query element. Okay, I want to find this particular index, that my current query is lying in which particular index. Okay, and if you know, this lower bound function of vectors returns an iterator variable. So okay, so you subtract it with the first iterating variable to get this index. So this will give you the index number. So k is nothing but the index number of the presence of index value of present of index, or you can also say query I, the presence of query I. Okay, what is it? I'm just trying to copy this, right? Okay, so yeah, of the presence of query I in vector v. Okay, and where v is the position of the vectors. Okay, so the index number of the presence of this. So yeah, I got that index number with me, and in order to get the next element, what I can do? Vk plus 1 left. For the left element, what I will do? Vk minus 1, right? And for the right element, what I can do? Vector of k plus 1. So that's what. Once you get the positions, you can just do k plus 1 and k minus 1 to get the left and right. But hey, not exactly this. This is a circular array. So you must write this thing. Okay. So let's say int n equals to v dot size. It's a circular array, right? So what happens if you are at the first element? Okay, what happens if k is 0? What happens if you are standing at the first element? So you want to go to the last element now. Okay, you want to go to the last element. So this is the thing you do. I hope you do understand. It is not very difficult. And for this, what if you are standing at the last element? You go to the next element, means you want to go to the first element. Okay, so n minus 1 index, if you add, you go to the n index, and if you modulo that, you go to the first index again. So that's how you just extract the left and right, and you get some left distance and right distance is this way. So distance of 1, what will that happen? Distance of 1 will be nothing but the absolute value of distance uh, between, you see, what is your current index? Mm, it's k, right? Uh, it is so distance we need to find with respect to this number. So this index I need to consider. Okay. Now index number minus uh, left. Okay, you can do this, and distance 2 also you can calculate. How? Index number minus right, and at the end you can just do answer dot pushback of distance 1 and distance 2. That is what you can do. So let's see, let's try to run this and check if it works or we have some error. Okay, so for now we uh, do have some error. So this, we need to return the minimum value in this of uh, the left distance and the right distance, right? So if you try to see something, this answer we are getting as a wrong answer. Okay, so what do you understand from this? Our output is 4, but the actual answer is 3. So what exactly is happening? And query is of 5. So let's take this example and try to analyze in detail. You will understand what is the very mistake that we did, and it is simple only. So we have 1 3 1 4 1 3 1 4 and 1 3 2, and you want to search 5, right? Queries of, what does it give you? The last element, right? This is the last value which is giving us the mistake. So 5. So fifth index, which is the fifth index over here? Okay, this is the fifth index, and which is the nearest one? This one. Okay, so now what is the distance? 1 2 3 4. Distance is 4. If you go to the left, what happens if you go to the right? You end up in skipping this boundary. So if I go to the right, distance is 1 2. If you from here to here, 2, and then 3. Distance, if you go to the right, it is 3. So what is the minimum of 4 and 3? It is 3. But what I am returning? I am returning 4. Okay. So I hope you do understand. Our answer is 4, but we should return 3. Even we did minimum, since still this is coming. Why is it so? Because we did not consider the circular distance. Okay, so what will be the circle? See, we just went, see what will the value of vector store. It will store the positions, right? So this is in position 1, this is in position 5. So it will store that 3 corresponds to the position 1 comma 5. So this is the map where map configuration of 3, right? When it is at position 5, it will go to position 1 for sure. It will go, when you are going right, it will go to position 1 for sure, but it will see that, hey, it is still the position 1, and when I subtract 1 from 5, the absolute value, or 5 from 1, whatever, you get 4. You did not get this. Okay, but in order to get that, you must subtract it from the length. Okay, so what is the length of the vector? N equals to 7. Okay, and 7 minus 4 is 3. So that's how you get the a circular length. Okay, so n minus 4 also you need to do. So you need to minimize among this also. So I did not consider the circular value element. So circular value element distances. Circular value distances. How will I consider that? I will do distance 1 is equals to minimum among distance 1 and n minus distance 1. Okay, that is what I will do with distance 2 also in order to get it. And yeah, that will be all done. If you try to run it, I hope it will work just fine. Yeah, it works for these two test cases. Let's try to submit it for all of them and check. Okay, so it did get we did get a TLE for this. Yeah, mostly we should not be getting it. Let's try. See, this unordered map gives you an amortized O of one-time complexity, but the worst can also be up to O of one, O of n. Okay, uh, this map gives you an O of log n always. Okay, something like that. So if I try to submit this, I hope this should work, because in some exceptional cases of when only one is present, it is giving you a TLE. But this time, okay, so uh, this time also it does give you a TLE. So why does it happen? Because I submitted quite a similar value and did not get TLE. So let's try to check properly, because not solutions, submissions. I did submit it and solve it before starting the video. So yeah, that time it got accepted, right? So we have this thing and this thing. The answer queries plot size. Uh, okay, so for every time it is not storing it as a different address. So for every query, if you do vector of v, it will try to store in different addresses. That will take a lot of time. Okay, so that is the thing which is different, I guess, only, and that might give you a TLE, right? You should try to avoid storing this vector. So use the same memory space again and again. So by using a AND, you're using a same memory space again and again, and you do not bother whether it is you overwrite the values or not, because every time for every query you get the new value, right? So that is only the thing. I hope you did understand. Yeah, it was quite interesting, I would say. This difference is making you TLE or not TLE difference. It's quite interesting. And if you do get some optimized solution, you can definitely write in the comment section, because this is the solution which I could come through. And yeah, that's all for this video. If you have any doubts, you can ask me in the comment section. I will definitely answer. Let's meet in the next video. I hope you did understand the solution. Yeah, that's all. I will meet you in the next video. Thanks a lot.